Yes. So very good morning to all of you. Welcome to new topic and new session. Before going to start, a very happy friendship day to all my viewers and my well wishers and to all my friends. Very happy friendship day. So friendship is one of the relation we cannot see, but this is most powerful and valuable invaluable relation. So once again, a very happy friendship day to all of you. So in this video, I'm going to explain a topic called divisibility and divisibility rules. This is one of the most powerful logic in aptitude. If you know golden logics, I have 7 golden logics. In those golden logics, this divisibility rule is one among those 7 golden logics. If you know divisibility rules very well, you can crack many of the aptitude questions as quickly as possible and as simple as possible. This is the reason why once the candidate knows the divisibility rules very well, he will be much more good at aptitude questions. And this divisibility rules we can definitely get 1 or 2 questions in all the placements. You will definitely get 1 or 2 questions on divisibility rules and all these competitive examinations. So the topic that I'm going to present will be useful for your career. So listen repeatedly and let us start. Must learn divisibility rules. First divisibility rule is divisibility rule of 2. How to know whether a given number is divisible by 2 or not? Just see. 248 is divisible by 2 or not. What we are going to do? We are going to check whether the given number is even or odd. Whether the given number is even or not, that we can find out from the unit digit. By observing the unit digit, we can able to know if the unit digit is even or if the unit digit is 0, 2, 4, 6, 8, then we can decide that it is divisible by 2. So what is the divisibility rule of 2? Checking or examining the last digit. Checking or examining the last digit, which is nothing but unit digit. If the last digit is divisible by 2, number also divisible by 2. For example, 247, whether this number is divisible by 2 or not, definitely not divisible because the last digit is 7. 7 is not divisible by 2. If not divisible by 2, what we are going to get? If not divisible, we are going to get the remainder. Now 7 divided by 2, remainder is how much? Nothing but the remaining part is 1. The same remainder will be obtained if you divide 247 by 2 also. This is the concept of divisibility rules. This is the objective of divisibility rules. We are not interested in 247 by 2 remainder. We are interested in 7 by 2 remainder. If 7 by 2, definitely not divisible. So if not divisible, what we are going to get? Remainder. How much the remainder of 7 by 2? 1. The same remainder will be obtained if we divide 247 by 2 also. Now what is the divisibility rule of 2? Last digit or unit digit. That's it. Now divisibility rule of 4. 4 is nothing but 2 square. Last 2 digits. 2 is nothing but 2 power 1. Last digit we are concentrating for the divisibility rule of 2. Now for the divisibility rule of 4, what we are concentrating? Last 2 digits of the given number. For example, 1244. whether this number is divisible by 4 or not. Remember viewers, divisibility rule of 4 is very important. To what is the divisibility rule of 4? Check last two digits. If the last two digits of the given number is divisible by 4, then the entire number also divisible by 4. Here last two digits are 44, 4. 44 is divisible by 4. So the number 1244 is divisible by 4. Let us take one more example. If 1245, whether this number is divisible by 4 or not. What are the last two digits of this number? 4, 5. If 4, 5, 45 is not divisible by 4. If not divisible by 4, what we are going to get? Remainder. What is the remainder of 45 by 4? 1. The same remainder will be obtained if we divide 1 to 4, 4, 5 by 4. So the remainder is 1. So what is the divisibility rule of 4? Last two digits. Now divisibility rule of 8. 8 is nothing but 2 cube. 4. Divisibility rule of 4. 2 square. Power is 2. We are checking the last two digits. Divisibility rule of 2. 2 power 1. We are checking the last digit. Now 8 is nothing but 2 cube. Power is 3. We are going to check the last three digits. The number formed by the last three digits. Last three digits. Just take 7 to 4, 8. Whether this number is divisible by 8 or not, that is our question. 7 to 4, 8. Whether this number is divisible by 8 or not. How to check? Check the number formed by the last three digits. The number formed by the last three digits is 248. 8 3s are 24, 8 1s are 8. So no remainder, perfectly divisible. So this number is divisible by 8. 248 is divisible by 8. So definitely 7248 is also divisible by 8. So we have to check only last three digits. Let us say 7249. Whether this number is divisible by 8 or not, what we have to do? The number formed by the last three digits is 249. Whether 249 is divisible by 8 or not. 7 3s are 24. Okay. 8 1s are 8. The remainder is 1. Not divisible. If not divisible, what we are going to get? Remainder. Here the remainder is how much? 1. This remainder is 1 for actually for 249 by 8. The same remainder will be obtained if we divide 7249 by 8 also. This is the concept. So 7249 is not divisible by 8. If not divisible by 8, you are going to get the remainder. How much the remainder? This 1. That's it. That is the divisibility rule of 8. Divisibility rule of 2, last digit. Divisibility rule of 4, last two digits. Divisibility rule of 8, last three digits. Now divisibility rule of 11. Let us see. 143, 143. This is the number. Whether this number is divisible by 11 or not, that is the question. Now what is the divisibility rule of 11? Sum of the digits in the odd places. 1, 3. This is first odd places. The digits in the odd places is 3, 1, 4. You have to do the process in this direction. Right? 3, 1, 4. These are the digits in the odd places. Counting in this fashion, which is important. Minus sum of the digits in the even places, which is nothing but 4 plus 3 plus 1. That's it. If this difference is 0 or multiple of 11, numerator difference, if this difference is 0 or multiple of 11, then that number is divisible by 11. That's the concept. Let us see. 3 plus 1, 4. 4 plus 4 is 8. Sum of the digits in the odd places, minus 4 plus 3, 7. 7 plus 1 is 8. Sum of the digits in the even places. This difference is 0. So the number is divisible by 11. That's it. Over. That is the divisibility rule of 11, my dear viewers. So the divisibility rule of 11 is what? Sum of the digits in the even places minus sum of the digits in the odd places. If this difference is divisible by 11, if this difference is 0 or multiple of 11, then the given number is divisible by 11. Let us see one more example. 143, 145. Whether this number is divisible by 11 or not, that is our question. Let us see what sum of the digits in the odd places. This is the direction you should work out, which is nothing but 5 plus 1 plus 4, nothing but 10. Sum of the digits in the odd places minus sum of the digits in the even places. 4 plus 3, 7. 7 plus 1 is nothing but 8. 10 minus 8 is 2. 2 is not divisible by 11. So this number is not divisible by 11. That is perfect. If not divisible, we have to get the remainder. Then how much the remainder? 2 by 11. Remainder is how much here? 2. The same remainder will be obtained if you divide the number 143145 by 11. 143145 divided by 11. How much the remainder? 2. This is the concept. Remember, my dear viewers, divisibility rule of 11 is also very important. Sum of the digits in the odd places minus sum of the digits in the even places. If this difference is divisible, if this difference is 0 or multiple of 11, then the number also divisible by 11. That is now. Next, another important divisibility rule is nothing but divisibility rule of 3. What is the divisibility rule of 3? Is nothing but SOD. SOD is nothing but sum of the digits. SOD in my view is nothing but sum of the digits. If sum of the digits in the given number is divisible by 3, then the number also divisible by 3. Let us take the example 3 to 6. Whether this number is divisible by 3 or not, what we have to do? Sum of the digits. 6 plus 2 is 8. 8 plus 3 is 11. 11 is the sum of the digits. Is 11 is divisible by 3? No. If not divisible, what we are going to get? Remainder. 11 by 3. Remainder is how much? 3 2s are 6. 3 3s are 9. Remainder is how much? 2. Remainder is how much? 2. So if 326 by 3, we are going to get the same remainder 2. Same remainder 2. That is the concept. 3 3s are 9. The remainder is 2. 11 by 3, remainder is 2. The same remainder will be obtained if you divide 326 by 3 also. One more example. 366 divided by 3. Whether 366 is divisible by 3 or not. Let us take the sum of the digits of the given number. 6 plus 6 is 12. 12 plus 3 is 15. This is the sum of the digits. So 15 is divisible by 3. So 366 is also divisible by 3. Same logic for 9 also. The divisibility rule of 9 is also same. Here I am telling divisibility rule of 9 also. What is the divisibility rule of 9? It is nothing but sum of the digits. If sum of the digits is divisible by 9, number also divisible by 9. Let us see. 2, 4, 7. Whether this number is divisible by 9 or not. Let us take the sum of the digits. 7 plus 4 is 11. 11 plus 2 is nothing but 13. Whether the 13 is divisible by 9 or not. 13 is not divisible by 9. If not divisible, what we are going to get? Remainder. 13 by 9, remainder is how much? 4. 13 by 9, remainder is 4. The same remainder will be obtained if you divide 247 by 9 also. So 247 by 9, remainder is how much? 4. One more example, 369981. Whether this number is divisible by 9 or not, we will check. 8 plus 1, 9. 9, 9, 9, 1, 2, 3, 4. 4 nines, 4 nines are 36. Sum of the digits is 36. Yeah, 36 is divisible by 9. So this bigger number is also divisible by 9. That's the concept of divisibility rule of 3 and 9. That's it. Now we'll see divisibility rule of 6. What is the divisibility rule of 6? Right? Just see. 6 is nothing but 2 into 3. It means if a number is divisible by both 2 and 3, if a number is divisible by both 2 and 3, then it is divisible by 6. This is the concept. You have to check both the divisibility rules. If a number is divisible by 6, it means it is divisible by both 2 and 3. For example, if you 1297345, whether this number is divisible by 6 or not, straight away we can say this number is not divisible by 6, because only even numbers are divisible by 6. That's it. So divisibility rule of 2 is what? Last digit. Here the last digit is 5. So not divisible. If the number is not divisible by 2, then it is not divisible by 6. That's it. It means the number has to satisfy both the rules. It should divisible by 2 as well as 3. Then only it will divisible by 6. So here the number is this one. Here this is not divisible by 2. So not divisible by 6. If not divisible by 6, we have to get what? Remainder. In this case, remainder is how much? 5 by 6. In this case, remainder is how much? So 5, the remainder is 1. Right? We'll see the remainder in this case. We will see remainder in this case. We will see remainder in this case. If not divisible, we have to get the remainder, right? That is the reason why remainder is important for us. Let us see the remainder. 1213. Whether this number is divisible by 6 or not? Definitely not divisible, because the unit digit is 3. Not divisible by 2. So no, there will be a remainder. How much the remainder? We will see. Generally 3 by 2. We are checking the divisibility rule of 2. Right? So for the divisibility rule of 2, remainder is how much? 1. Whether the same remainder is obtained or not, we will see. 1213 divide by 6. 6 2s are 12. 103. 6 2s are 12. Definitely we through. How much the remainder? 1. So 3 divided by 2, remainder 1. The same remainder is obtained if we divide the entire number by 6 also. 6 also. Right? That's it. That is the divisibility rule of 6. Right? Once again, I would like to explain divisibility rule of 6. 2413. Whether this number is divisible by 6 or not? Definitely not. If not, what we have to get? Remainder. For that, what I am checking, if a number is divisible by 6, it must be divisible by both 2 and 3. What is the divisibility rule of 2? Last digit. Last digit is 3. 3 by 2, not divisible. We are going to get the remainder 1. So the same remainder 1 is obtained if you divide 2413 by 6. That is the concept. This is the concept. If we want, we will check. I want to check, I want to cross check. 2413. Let us do the divisibility of 6. 6 fours are 24. Right? 1, 0, 3. 6 twos are 12. Remainder is how much? Perfect. Remainder is 1. That's it. Now, divisibility rule of 7, right? I will explain divisibility rule of 7 in the next slide. This is, just read what is the divisibility rule of 7. Double the last digit and subtract it from the number formed by the remaining digits. Let us see. 247. Whether this number is divisible by 7 or not. What is the process? Double the last digit. 7 into 2 is nothing but 14. Then what is the remaining number? 24. 24 minus 14. This is what? Subtract from the remainder. Double the last digit, subtract from the remaining number. 24 minus 14 is 10. 10 divided by 7, not divisible. If not divisible, we are going to get the remainder. 10 by 7, remainder is 3. The same remainder is obtained if you divide 247 by 7 also. Right? The process is what? Double the last digit and subtract from the remaining number and repeat this process. Repeat this process. I will explain with one more example. 121432 divided by 7. Whether this number 121432 is divisible by 7 or not. That is what I am explaining. So what is the process? Double the last digit. Last digit is how much? 2. I am doubling. 2 into 2 is 4. What is the remaining number? 12143. This is the remaining number. Minus 4. How much we are going to get? 12143 minus 4, 39. 39. This is the remaining number. If you are comfortable with this number, you can do this process. Otherwise, you can repeat the process. What is the process? Again, double the last digit, 9. So, remaining number is 1213 minus 9 twos are 18. Doubling the last two digits. Now, 1213 minus 18. 13 minus 8 is 5. Right? This is 0. 10 minus 1 is nothing but a 9. This is 0. This is 1. That is 1095. 1095. This subtraction is 1095. If you are comfortable with this number, you can divide by 7. Otherwise, repeat the process. What is the process? Double the last digit. 109 is the remaining digit, remaining number, minus 5 twos are 10. Double the last digit. That is 109 minus 10, which is nothing but 99. Right? If you are comfortable with this number, okay, you can perform by 9. Otherwise, repeat the process. Repeat the process. Now 99 by 7. 7 ones are 7. This is nothing but 2. 7 fours are 28. Remainder is 1. Finally, we threw, and the remainder is how much? Remainder is 1. The same remainder 1 is also obtained if we divide this entire number by 7. That is the process. Definitely 121432. This number is not divisible by 7. If not divisible by 7, we have to get the remainder. Remainder is how much? 1. Now, in this example, you can definitely understand that this doubling the last digit and subtracting from the remaining number and repeating the same process till the comfortable number is obtained. Right? This is definitely a time consuming process. That is the reason why this process I am encouraging only for the smaller numbers. This process of doubling the last digit, subtracting from the remaining number, will be comfortable and faster for the smaller numbers. If the number is a bigger number, this process is really a time taken, right? So that is the reason why I'm going to explain one more process, right? One more shortcut method, or the divisibility rule of 7 for the bigger numbers. This is also applicable for the smaller numbers, but for smaller numbers, doubling the last digit, subtracting from the rest of the number is easy, but for the bigger numbers it is difficult. Now what is the another divisibility rule? Let us see. 1 2 3 1 4 3, whether this number is divisible by 7 or not, right? Now in this way, or in this direction, the direction that I was marked with the arrow mark, in this direction, group of 3 numbers, form the group of 3 numbers. So the first group is 1 4 3, next group is 1 2 3, form the 3 numbers group. Then what we have to do? Assign plus minus, sum of the positive groups minus sum of the negative groups. Here sum of the positive groups, only one positive group. What is the negative group? 1 2 3. If this difference is divisible by 7, number also divisible by 7. That's the concept. Now 143 minus 123. Difference is how much? 20. Is 20 is divisible by 7? No, not at all. If not divisible, then this number is also not divisible. That's it, right? So we got the conclusion that 1 2 3 1 4 3 not divisible by 7, because here the difference is 20. 20 is not divisible by 7. Now if not divisible, what we have to get? Remainder. How much the remainder? 20 by 7. Remainder is how much? 7 2s are 14. Remainder is 6. The same remainder 6 also obtained if we divide 1 2 3 1 4 3 by 7. That's it. Now the remainder of this one is how much? 6. That is, this is the most comfortable way. Right? Now one more example on this. 1 4 3 1 4 3 1 4 3 1 4 3. Whether this number is divisible by 7 or not, let us see. Right, in this direction, take a group of 2 3 1 4 3. This is first group. Next one more 1 4 3. Next group. Next 3 1 4 3. Next 3 digits, which is nothing but 1 4 3. Now plus minus, sum of the positives. 1 4 3 one positive group, 1 4 3 another positive groups. Sum of the positive groups minus sum of the negative groups. This difference is 0. So 0 by 7, remainder is how much? 0, which means the number is divisible by 7. So this 143 143 143, nothing but a 12 digit number. This 12 digit number is divisible by 7. That's it. Now from this example, if I extend this concept, what is this? A 3 digit number, If a 3 digit number is written even number of times, here how many times? 4 times. If a 3 digit number has been written even number of times, that number is divisible by 7. One of the most important shortcut that you candidate has to remember, right? If a 3 digit number has been written even number of times, that will be divisible by 7. Let us take 241 241 241 241 241. Let us say this is my number. Whether this number is divisible by 7 or not, that is the question. Or if this number is divided by 7, what is the remainder? That might be also the question. Then here see 241 241, 241, 241. The same 3-digit number has been written 4 times. 4 is even, so definitely divisible by 7, also divisible by 11, also divisible by 13, also divisible by 77, also divisible by 91, also divisible by 143, also divisible by 1001. If a number, if a 3-digit number, if a 3-digit number is written even number of times, then that number is divisible by 7. That's the concept. Now this concept can also be extended like this: 1 1 1 1 1 1 1. How many times? 1 2 3 4 5 6, right? 6 times, right? If a single digit is written 6 times or multiple of 6 times, right? If a single digit has been written 6 times or multiple of 6 times, then that number is also divisible by 7, 11, 13, 77, 91, 143, 1001. That is, both concepts are similar. If a 3-digit number is written even number of times, that is divisible by 7, 11, 13, 77, 91, 143, 1001. Or if a single digit, if a single digit is written even number of times, even number of times, or sorry, not even number of times, 6 times or multiple of 6 times, then that number is divisible by 7, 11, 13, 77, 91, 143 and 1001 also. To all these numbers, that number is divisible. That is the concept. That is the concept. I hope you understand very well. The entire thing I has been mentioned in this slide very beautifully, right? These are the divisibility rules that I would like to explain in part 1. I will upload one more video on the concept of divisibility rules. Only the divisibility rules I will do 2 videos, and the problems, different types of varieties of questions which are originally asked in placements and competitive examinations, that I will upload in part 3 and part 4. If you listen part 1, part 2, part 3, part 4 repeatedly, you will get much more confidence in divisibility rules. Remember, my dear viewers, divisibility rules is one of the most powerful technique to solve many of the aptitude questions. That's the end of my session 1 or part 1 in divisibility rules, right? Thank you one and all. Have a nice day. Once again, a very happy friendship day to all my viewers. Thanking you.